Hi again, folks. How you doing? Welcome back. Okay, let's go. So this is the third little part of the integration applications. So again, we're looking at area here. And it looks as if we're going to have a wee picture here because they've given us two curves here. Y equals a half and y equals cos x. So we're looking at of the area enclosed or bounded by them. Okay. But, but notice here that they're talking about either side of the x-axis about this cosine curve. That's important because cos x is infinite. It just goes on forever and ever. And y equals x, actually, it goes on forever and ever. I'll just, I'm just going to try and emphasize this here. So cos x, so it's something like it goes on, it goes like that. Just right. My art skills are not brilliant, but kind of goes like that. But y equals a half. That's at height a half, and obviously that's not at height a half because my diagrams are rubbish. So let's pretend that's a half. Okay. So if they're saying that's a half, so area bounded would be that there. That's what they're trying to say. That's a wee bit there. Right. That's actually the region I'm talking about in this question. But if I didn't really specify things, then actually there's an area enclosed there, 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 and forever and ever and ever and ever. Right, so there's too many. So what I'm looking at is located either side of the y-axis. I should have said specifically a region. So that's what I'm looking at here. This region here. Before we all got upset and you start sending in letters to the director of the BBC or whoever. So that's what we're looking at here. Okay, am I quite? Are you quite clear? That were sorted out what are known as the boundary condition. So have we sorted them out in your head? Have we sorted these out? Please let me know. Have we sorted them out or have we not sorted them out? And for some reason, these don't want to disappear. Right, I'm just going to get rid of these here, folks. Right, that's okay. So, that's the region I'm talking about. The line y equals a half, which is horizontal, and the curve, or part of the curve, y equals cos x. So I'm talking about that region, that watermelon in there. That's what we're talking about here. So, several things that we need to deal with here. And we need to know the extreme point left, the extreme point right, the upper curve, and the lower curve. That's what we're looking for here. And then that means we can encapsulate the area of interest. That's what we're looking for here. Okay, so let's go for it. So let's get extreme points left, extreme point right, it's limits of integration. And we're coming down from the diagram here, and I'm coming down to the x-axis here. Yeah. So that's the values of x I'm looking for here. So I'm going to make a half equal to cos x. Y equals a half equals cos x. That's what I'm looking for here. So I'm going to go and solve this. And so to get rid of cos, I get inverse cos of a half. Okay, right, we're dealing with hopefully positive answers here. We're dealing with dimensions, or are we? I might rewind on that. We're dealing with answers with the function values close as close to 0 as possible. So if we were dealing with degrees, so that's actually a quarter of the function there. To that point there is 180 degrees, and that point there is 90 degrees. That point there would be negative 90. So we're dealing with values between that. Your calculator is going to give you an answer between 0 and 90. So we'll just go and go for the positive value of that there with a calculator. Right. So just take the inverse cos of a half, and that should be a very nice answer. Inverse cos of a half. What would that be in degrees? That would be 60. But we are going to be dealing with the radian measure here. So that would be pi over 3. Okay, you know, in your calculator, your stupid calculator, beep beep, undo, inverse cos of a half. Your calculator says 60. It doesn't say 60 degrees because it does not know it's working with angles, okay? It does not know that, but we'll put it in. In terms of radians, that's pi over 3. But you should know that. And the reason you should know that is because you're clever. And you know, because you're so clever, you just multiply by pi and divide by 180 degrees. And that part there is 60 over 180. That just gives you 3. And the pi part stays the same. And that's why we get that. But you are so clever. Oh, am I just lathering you up with patter here? You're so clever. You know it's pi over 3. Or the decimal equivalent. Okay? So you just go for that. Right. Okay, we've got to there. Pi over 3. Okay. But we've got an error here. The answer we've got, pi over 3, is positive side of the x-axis. So that's that value there. Right, but we need this value here as well. That's another bound. But if you look at them, by symmetry, they're identical apart from the sign. They're identical. So we've got pi over 3 there, and the other one is negative pi over 3. If you want to work it out another way, do so. Okay, so what I'm saying that is by symmetry, not in the graveyard, by symmetry. Okay, so it looks like we can go and work out the area. I'm actually going to write this down here. So the area is the integral of negative pi over 3, top minus bottom. Right, I'm putting this down here just so we can see the picture with regards to x. That's what that means. So the top minus bottom. So what we're going to have for the top minus bottom? So the top curve. Yes, so the top curve is, what's the top curve here going to be? So the top region, that's going to be the curvy part, is cos x. So that's why I'm going to have cos x here. And I'm going to be subtracting. You always subtract here. And we're going to be subtraction y equals whatever that is. So that's going to be just a half. Right, and maybe bracket that up for safety. So I'm going to be integrating cos x minus a half. And then I've got my limits. So I'll put them in later. Okay, I'll put them in later. Right, here we go. Next stage. Top minus bottom. There's my limits. Okay, top. There you go. I've just showed the picture there again for the non-believers. Cos x is definitely top. Y equals a half is definitely bottoms up. Because x take away a half between the limits. Negative pi over 3 in the bottom to pi over 3 in the top. There you go. Let's integrate. This is the only integration part. Everything else is, well, we integrated it, right? Yet we followed the rule. Okay. Or we've not integrated yet because we don't know what the integral of cos x is, but we do. So we'll integrate cos x and we'll integrate negative a half. Just think about integrating a half and think of the wee line between them being a minus. So integral of cos x should be sin x, and integral of half should be half x. And yep, we've got the limits from the right hand side there. I've just moved them there. That's normal practice in Tommy's class. So we've done that there. So let's take that sin x take away half x and copy and paste it. 2 occasions. There you go. It's identical. Take the upper limit pi over 3. Take the lower limit negative pi over 3. And pi over 3 in the first one. Negative pi over 3 in the second one. And let's start working them out. Okay. You should be at a stage where you should recognize these as exact values. If not, use your calculator and don't start complaining to me that you don't understand that the sine of pi over 3 says 0.866. It should say root 3 over 2. So go and sort out the modes. So it gives you it back as a surd, whatever a surd means to you. So you need to understand how your calculator works, not me. So sine of pi over 3 gives you root 3 over 2. Take away half of pi over 3, that's just pi over 6. Take away pi over 6. Next one. So, right, I'm just going to write this down here. This is the way it should come up in your good calculator. This one here, sine of pi over 3 should be root 3 over 2. That there should be just pi over 6. And you're going to be taking away sine of negative pi over 3. Oh, that would just be negative root 3 over 2. And then you would take away 1, take away pi. Oh, wait a minute. 1, that would be a positive actually. Pi over, that's made by 6, not a 0. Okay, we'll get that there. And so we'll just gather like terms here. So take the sub parts here. So you root 3 over 2, you're taking away a negative root 3 over 2. So that would give you 2 times root 3 over 2. And if that's the case, the 2's will cancel. And that will just give you root 3 give you root 3 there. Next part, negative pi over 6. Have I made a mistake here? Right, so I've got negative pi over 6, and I'm taking away positive pi over 6. So I'm going to be taking away 2 lots then. So if I do that there and that there, it gives me root 3, take away pi over 3. That's what it looks like the answer is to me. And pi over 3, that's approximately, well, I'm going to 1.7, 1.768 to 1.04 approximately. Right, let's see what I've got. I did the same, right? So I'm just doing this off the hoof. Off the hoof means in my brain. Let's see, what did I have? Yeah, root 3 over 2, pi over 6, that's it. Yep, get the like terms. Okay. Oh, please notice here what I've done. I don't like this myself. I've used the negative incorporation with that there in order to get that there. Right, that's what I've done there. And I've just went back a page or two, just for my own benefit, or not, just to annoy you. Yeah, there you go. Here we're back. Apologies. Right. Root 3 over 2 plus root 3 over 2 is 2 root 3 over 2, it's root 3. Negative pi over 6, take away pi over 6, negative 2 pi over 6 is pi over 3. Negative. Right. Okay. That answer will be fine there, folks. That's a beautiful mathematical answer. But sometimes you like decimals. Right, so you might go in, you might want to decimalize that. That's fine. So I would leave it as that there. But the thing is here, when you're working with the radians, even though if you think, oh, that answer, that angle's, I know pi over 3 is 60 degrees, or pi over 4 is 45 degrees. Don't work in degrees, because you might have other numbers within the calculation that are not explicitly in degrees. So change to radians, because radians have no units of measure. And basically that kind of means that they can wear the clothes of any other units of measure. That's what that means. So I'm going to leave this one here, folks, okay? Definitely. I'm going to leave it for you. Right. Okay. So bye for now.